Hello, my name is Joe Romanyk, and this is my CE 570 Project 1 MATLAB Introduction. So the goals of Project 1 were to gain familiarity with MATLAB by defining the parameterizations for a 3D body, a curve, and a surface of your choosing. So the object that I chose to model in MATLAB was a cone with radius 3, height of 2, covering an angle theta of 2 pi, and the surface portion will be 25% or a quarter. So for parameterizing our object, we first have to parameterize our geometry, our grid, the surfaces, and the curves of our object. So for our cone here, we have our top surface, which looks like a circle, is surface 1. Our surface 2 is our curved surface, going from a radius of 3 all the way down to a point. And then we have our curve 1, which is this angled portion on surface 2, and then our circular curve 2, which details surface 1. So I began by parameterizing the body with variables rt and z, where x1 is r times cosine theta, x2 is r times sine theta, and x3 is h over the radius times r. So the reason why in our parameterization that it's not just h for x3 and instead it's h times r over big R is that if we were to plot this as just h, it would be plotting as a cylinder. We wouldn't have any variation. So if we're changing with respect to r, we start with r equals 0, then we'll be at a point, while when little r is equal to 1, we would have the radius of the circle. So we can get this cone shape rather than our cylinder shape. So defining our grid is going to define how many points are plotted on our body. So we're just doing 0 to r, 0 to theta, and 0 to the height. So, and we're doing it in increments of r over, or our variable over n. I chose, I believe, 2 times the amount as, or 2 times our length values or theta values as our increments. Then we define our surface. So our curved surface is defined at a radius of r varying with theta as well as our height. And then our flat face, which is our circular face, will only vary with our radius and the angle, and it won't vary with height, as we only have that circular surface, that flat circular surface at the very bottom. So for our curves, we define our top point as being 0 to radius of always equaling 0, our theta being from 0 to theta, and then our height. This point was actually not needed, but I thought it really helped define our shape better while looking at the code. This could also be, instead of 0 to theta, it could be 0. And then our circular curve is going to be at a radius of r varying from theta, so we can start with a radius r from the origin, and then we'll draw our circle based off of our value of theta. So when we type this into the code, this is the shape that we received. So next was defining a curve. I chose the curve here that's showing at an angle. You can see how I defined it here. It's going to vary along our x3 coordinate, varying with c. And then here's how it plots. So we can clearly see that it plots along the side. When we're defining our surface, I chose to do a quarter of our curved surface, and here's kind of how I parameterize it with r times cosine theta, and it's going to be varying with s as shown here, and as well as t. So similar to our curved surface, except now we're going to be varying the angle. So instead of it being a line, we'll now be able to draw our surface as it varies with theta. So here's if we get one segment, it goes from the point to the top. If we do 10 sections, we have this. We have 10 different sections. And then here are our results for length, very similar. We used the equations given in the lecture slides in order to do this, using length as an integral, as a single integral, and the area of our surface as a double integral. So since our length segment is just a straight line, we should get the exact same result without needing to do a very large increment. With our only increments of 10 around our surface, we get a pretty similar answer of 9.3154 versus the theoretical correct answer of 8.4954. And if you'd like to see the handwritten work for that, I've listed on this slide, but in order to respect everyone's time, I won't be going through it. Thank you.